Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back again to the NPTEL online certification course on research methodology for planning and architectural studies. In our last lecture, we have discussed about mixed method research approach, where we have discussed several type of mixing, the design mix, the parallel, conversion, sequential or integrated, where we have understood that depending on the research questions, the researcher may go ahead with the mixed method, where a qualitative research method can be used to quantify like something, and then also for the quantitative research will like try to get certain inferences. So altogether the findings are compared and findings are like you can see the diversity or maybe you can say the similarity in findings, and then finally you can infer your result through this. And the advantages of mixed method also, like we discussed, where some of the research questions which cannot be answered fully with the standalone quantitative or qualitative research method. In those cases, like depending on the research questions, you may choose a proper mixed method, right. So in today's lecture, we will be discussing on a case study where the researchers used a mixed method approach to confirm certain question, right. So without any further delay, let us start today's lecture, lecture number 52, mixed method research approach case study. So in this lecture, we will be discussing about a case study, and then we will try to summarize our understanding out of this. Here is the paper. This paper is on urban water supply. The paper titled Investigating the Relation between Performance Indicators of Urban Water Supply in India. The paper is co-authored by Aditya Bhandari along with me. It was published in the journal named Urban Water Journal of Taylor and Francis, and I have also given the citation as well as the DOI. So you can access, if you use this URL, you can access to this paper, and also the QR code. Now in this particular case, before I go into the slides further, let us just understand by title that what exactly we have done here. So if you recall, earlier we have discussed about the service level benchmark of water supply utilities. So in India, we have say 9 such kind of benchmark. We will discuss all these indicators once again, but some of them are like per capita water supply, quality of water, continuity of water, then it is related to some of the non-revenue water, etc. Now how they are related, right? Now in this case, definitely whatever the findings that we have, different urban local bodies they report, so we get certain values, right. These are all some sort of data, secondary data that we have. But at the same time, in this particular paper, we thought, why not to understand this relationship, whether the per capita supply will depend on other parameters or other benchmark. Can we just get certain idea from the expert, the field expert, that what they think, that how these factors they are influencing each other. So then we thought of making an expert opinion based approach which is of qualitative in nature. And then once we get certain sort of relationship, okay, so this is depending on this, this is not influencing this, out of the expert opinion, then we try to confirm that through the already data available, and then where we have used certain other method to compare. Then also we tried that this kind of findings, how they are varying across different type of water scenario, the base water level scenario. So the in this particular case we have taken certain secondary data. So based on that we have analyzed this. So where twofold method that we have used in this case. So that's why it is pertinent to this mixed method. Going ahead about the background of the research, that it is also known to all of us that water is very crucial for human survival, and it is also aligning with the sixth sustainable development goals of United Nations, which are targeting 2030 as target, which is emphasizing of universal water access. Urbanization significantly influences the water demand, introducing complexity to the urban water supply system. So for any city, whenever like water is being supplied from some authority, always they have a calculation that what is the per capita supply, or maybe you can see in that case could be the consumption, and then with a certain thumb rule which is being followed for a long time. Even in the benchmark they have mentioned about 135 liter per capita per day. So that is something that you multiply with the population and then you supply it for the daily uses. But obviously the consumption will not be same, maybe depending on the age, depending on the income, depending on the location, weather condition. There are many factors which are actually governing the water consumption. We may have a seasonal variation, maybe the uses in summer and winter will change, but for supply point of view, so there is some sort of benchmark that they said 135, which actually it's not same as reported by different urban local bodies in their reports that we have also studied, that somewhere it is more than that, somewhere it is even half of it, etc. But the main issue is that whenever you have more concentration to urban area because of certain opportunity, job, employment, education, good health care, and other few amenities that people are looking in the urban area. So more people are concentrating in a smaller area, so which is nothing but increasing the day-to-day demand of such utilities, like it is related to the power supply, sewage, so as true for the water. So there are certain sort of stress or pressure on this, where the demand is more and supply is not having that scope of augmenting or meeting the demand. So then there are certain issues. The planning and design of urban water supply system require careful analysis of resource availability. Indian cities managed by urban local bodies face challenges due to urbanization and water supply issues. In many cases, in India, what we face about the issues of uh, the losses, the water losses. Maybe it is something due to some of the poor maintenance, there are leakages, there are other issues, sometimes maybe there is some sort of issue of the water theft, etc. Now coming to the research gap, which is very important. The increasing urban population and inadequate water supply are critical issue in Indian cities, especially like the cities having more than 10 lakh population, the million plus cities. So, there is a urgent need to evaluate the water supply performance in cities, focusing on the efficiency, then dependability, and also the cost considerations. So, that is something that we observe, that sometimes water management is much more crucial than just to increase the source of water, because maybe sometimes we have good amount of water, but due to poor management things are not uh, happening. With that, the objective of study was set to investigate the relations between different performance indicators of service level benchmark of water utilities based on the knowledge of expert. This is first part, and based on the performance data is much more of the quantitative approach. So, in this case it is having some sort of sequential, not exactly sequential, we can say that this is something, you can say that the activity that was performed, they are parallel, but in some cases we also make certain sort of sequential approach to bring certain information from the first strands of the study to the second one. Here is the methodology of the study, where overall idea was to just check the performance indicators of urban water supply in India, where we have used the service level benchmark as our main document, and then we just uh, take the information that are available open source, which are filled by different urban local bodies, and also the population, where based on projected population in 2021, which are like having more than 10 lakh, the 1 million population that were taken into consideration. The first approach, as already I have mentioned, that was on expert opinion based survey. For that, we have used a method called interpretative structural modeling, or ISM, where expert opinion are converted to a self structure interaction matrix. From that interaction matrix, we go for initial reachability matrix, and from there you go for the final reachability matrix. Out of that, we can get some sort of driving and dependency power, and for that the method will also have certain sort of steps that if you go through the paper you can understand very well. We have certain level partition, we also make a digraph which is giving you the relationship, and finally the model. And also in this case we use this micmac analysis, where we finally classify the variables under autonomous, driving, linkages, and dependent. So, all this benchmarking, right, we have mentioned about 9 benchmarking. So, we just then finally plot into this, and then we classify into autonomous, driving, linkages, and then you have the dependent. The second part of this particular research, obviously based on the data that we have, here we have taken PCS, per capita supply, as dependent variable. Then we have taken all the Indian city, the population from 1961 to 2001, that population data. Then population we projected up to 2021, because the census was not available, and now also it is not available. Then we have taken all the cities with population more than 1 million, that is projected population, and accordingly we got something around 53 million plus city. Then we collect the service level performance data which are available for this 53 million plus cities. So, we have taken that into consideration. Then we classify all these cities based on the baseline water stress level, and we just make this category like low to high is one category, high is another category, and very high is another category. Now, why that is so? Why we have bifurcated those kind of information? It is something that what we observe that uh, the supply or maybe the other parameters that are reported, that is having some sort of relationship with this. Wherever you have certain sort of high water stress, so expected that you have certain sort of lesser supply, and then we try to establish the relationship. Then we just create the truth table preparation, then analysis of necessary conditions. So, in this particular case we have used the fuzzy set qualitative comparative analysis FSQCA. In that case we try to develop certain sort of recipe, to be the technical term, which is different sort of necessary condition, and then we just analyze the sufficient conditions or different algorithms, those recipe that which can act better to manage the water. The interrelationship between ISM variable classification and FSQC algorithm of different baseline water stresses are compared to bring out the solution. So, ISM has been used to frame a hierarchical relationship among the performance indicators based on expert opinion, where FSQCA has been used to understand the relations between the performance indicator based on the reported performance, which is already quantified. So, next about the survey design. So, for expert opinion survey, so here in this case we just show you one such kind of scenario where the questions were asked that coverage of water supply connections, which is one of the benchmark that is used, that affects the other. Like here we have the per capita water supply, extent of metering, extent of non-revenue water, continuity of water, okay, then extent of complaint readdressal, etc. So, in this case we have to just give whether it is affecting yes or no. This is as simple as that, and there are such kind of more questions where we just ask about this effect, like whether the per capita supply affects this or not, and then that is why like it is something the sample of expert opinion for coverage of water supply, which is COV. So, this was presented to the expert who are having more than say 15 years or so the experience in that field of managing water related aspect. Coming to the data collection, so this study has considered 5 experts to collect the service level benchmark performance indicator relationship for this interpretative structural model. Then in this case the expert answered 72 close questions, which is actually result of 9 indicators and possible 8 relationship, given that an indicator is wholly associated with itself. So, that was something that presented. Now, the second part of the study where we have used the FSQCA, 53 Indian cities were selected with a projected population of more than 1 million by 2021, and also for these cities we have that SLB data available. Now, coming to the rationale for the method selection, ISM was used to understand how expert envision the relations between performance indicators, how they are related, that the expert they feel. Individual expert they give their opinion, and finally we compare them and then the resultant of the expert opinion are finally taken into consideration. ISM assesses unidirectional and bidirectional pairwise relationship. That is one advantage. The micmac analysis and the diagrams help to understand the ISM result visually. So, this kind of structural hierarchy is very clearly represented through diagrams. Now, coming to the FSQCA that uses the Boolean algebra to find the causal combination of conditions known as algorithms between input condition and the output. FSQCA was used to validate the relationship established by ISM in 53 million plus Indian cities, and they are falling into three different baseline water stress region, which I already mentioned through the methodology diagram, like low to high, high and very high. Now, coming to the findings, definitely this method and other thing is explained in the paper. You can go through, you can very easily understand the steps. Now, this is the final you can say that plot where we have the dependency power in one axis, the other one is the driving power, and here we divided this quadrant like 4 quadrant. Quadrant 1 is the autonomous variable. There we found, based on the expert opinion, the quality of water QL is actually the autonomous. PCS, which is per capita supply, is the dependent variable. Next we have another two, which is your driving variables. So, here we have that there are two. One is the complaint readdressal, that how many complaints are addressed by the urban local bodies or the operators, and the collection efficiency of user charges. So, these are different driving variables. Now, coming to the dependent variables, so per capita supply is the dependent one, already it is being shown here. Coming to the linkage variables, so this is something like extent of metering, coverage of water supply connection, continuity of water supply and the extent of non-revenue water. So, these are the variables which are linked with the dependent variables, and autonomous is the quality of supplied water. So, which is not really affecting each other. This is based on the ISM. So, here if you see this particular diagram, so it has 4 labels. So, in label 1 we are having this quality of water supplied, per capita, and then operation and maintenance recovery. Then in the label 2 we have the collection efficiency and coverage. Label 3 we have extent of metering, NRW, and then you have the extent of complaint readdressal, and label 4 we have the continuity of water. The diagram depicts the hierarchical structure representing the relation between the indicators in the ISM. The direction of arrows depicts the direction of relationship. So, in some cases it is like double side arrow. So, they are having relationship, both are influencing each other, and somewhere it is only unidirectional. The indicators on lower levels of the diagram have more functional role in water supply, right, and the level 1 and 2 indicators of diagram play relatively minor functional role compared to level 4 and 3. Now, coming to the second part of this analysis where we have used this FSQCA, the first algorithm defines that the low base water stress cities with higher supply of hours, complaint readdressal, cost recovery and water charges collection efficiency potentially have higher per capita water. So, in this case if you see the cities where we actually can able to identify 17 cities, any 17 cities where we are having this low to high baseline water, where stress level it is less than 40%, and we have the combination of conditions where we have taken continuity, then you have this particular collection efficiency and all. So, there we have seen that the case of the membership. So, there is a membership value that are assigned higher than 0.5. So, we have received Navi Mumbai and Varanasi, where we have certain sort of consistency value is 0.981. Like that, in this particular approach, we have done for different sort of combination, that how this is going to change the output, because FSQCA there we are trying to make those combination and try to see that based on certain input what is the result in the output, the performance, how it is going to change. So, like that, these are standard table that we need to put. So, here we have given the consistency where some of the values are really of higher consistency. There are certain coverage value as well. So, in this case you can say the solution coverage and solution consistency, they are reported. So, you can get this kind of findings and more, like how to interpret this information and other thing. If you go through the paper, it is very well explained. The purpose of showing this particular table or this approach is to just tell you about this method. Now, it is not necessary that for all mixed method you will apply only these two. You can go for anything. So, in this particular case, definitely the expert based opinion, which is much more of qualitative nature, where the expert opinion was taken face to face interview, and then in this particular case it is based on certain kind of secondary data and we quantify under certain scenario. So, that is why I tried to convey through this case study. Now, coming to the discussion. So, Micmac analysis establishes that the PCS as the only dependent variable which has been used as an outcome or maybe dependent variable for FSQCA. So, that is why the algorithm, the condition that we have presented in this table, that is all related to the how it is going to change the per capita supply. FSQCA for the cities of 3 basewater stress scenario indicates different algorithms with different stress level. So, this is something additional, the further research that initially we were with the whole data set, and then we finally decided to go ahead with the further investigation, that is there any effect on the water stress or not. So, there we also found certain interesting finding. Increased supply coverage, metering, water quality, complaint readdressal, cost recovery and collection efficiency help in improving the per capita supply. A positive relationship between non-revenue water and per capita supply is expected to exist in cities with higher water stress, because the water stress cities import water from further distance, incurring high financial costs. So, for that they are really worried about that non-revenue water, because this is something where it can include the physical losses, or it may be something where the user charges are not properly collected. So, for such cases, like we have now seen some of the metro cities in India, so they are now getting this sort of signal about the water crisis and stress. So, they are importing water from a distance, which is undoubtedly increasing the overall cost. So, for that it is a concern definitely. Coming to the conclusion of this study, to achieve adequate water supply levels, cities with different BWS levels have different FSQCA algorithm. It is not same that everywhere you need the same treatment. The relationship observed in the ISM have higher validity in the cities with low to high 40% and high BWS. So, very high there are certain sort of result, but it is much more valid for the cities with low to high and high BWS. The cities with very high or more than 80% have anomalous relationship among the indicators. Reducing physical losses like leakages and unauthorized consumption of water, which is related to the NRW, and increased financial losses, which is like the subsidized supply, could be the potential reason for such diverse behavior in the cities with different BWS level. Okay, now coming to the take away from this case study. So, here I have demonstrated one approach where both like qualitative as expert opinion and then the quantitative analysis that has been done with those data that are discussed, where it is the application of a mixed method. This study actually helps water managers to understand the nature of the relationship between the service level benchmark indicators, where we have seen per capita supply is the dependent variable, and then you have some sort of relationship with others. This study also showcases a methodologically rich and comprehensive research design, combining the strength of interpretative structural model and FSQCA to explore, validate and contextualize the relationship across a large data set of Indian cities. So, this is something is very important. Like if we only perform this expert opinion, still we can get certain weightages, we can also establish the relationship, but then when we compare it with this actual data, the reported data, and you use certain sort of quantification, so then it is much more acceptable. And even we have seen that the results, especially for the BWS low to high and high, they are much more valid. In case of very high BWS, those cities there are certain sort of anomaly, and that is because of certain sort of issues that we have discussed. So, I suggest that if you are interested in this subject or in the method, you can go through the paper, and I am sure that with this particular presentation it is now clear that why sometimes mixed method is preferred over individual like qualitative or quantitative method. In this particular study, if we would have used only the expert opinion, probably we are missing those validation part, or if it is something like only we are just trying to do the quantification of what is there, so then also we cannot say that data may lead to some sort of output, but again when it is confirmed through the relationship that we observed in ISM, it is giving much more confidence, right. So, that is something like is one of the advantages of mixed method, where you can also confirm the relationship. So, with that I conclude here. So, to summarize, yes, it is a case study where we have used both the methods to bring out certain sort of findings, and they are complementing each other. These are some study material that you can go through. So, with that we conclude this mixed method, and now we will be discussing in our next lecture another important research method, and especially for planning and architecture is very pertinent, that is the spatial method, how we can use the spatial method for certain study. It is something that definitely whenever you require such kind of research of spatial in nature, then only it will be useful. It is not that in everywhere you can fit it. So, we will be discussing that, and also for this we will be discussing a case study as well. So, with that I stop here for this particular lecture. So, thank you for joining, we will be meeting you soon.